So I've had a couple of questions based on the previous video when we were looking at this quadratic function, this absolute value inequality, about plotting functions like this. How do we do that? Well, what do we do when we've got an absolute value with a quadratic, or if we've got an absolute value function plus some constant? Okay, so again, in fact, what we really want to do in a case like this is to break it down bit by bit. So if we want to plot f of x defined by minus 2x minus 3, well, the first thing that we do is we try to plot not this, but the function inside the absolute value sign. So instead of that, let's plot a new function which we're going to define by g of x equals x squared minus 2x minus 3. Okay, so what do we do here? Well, we see that it's going to be an upward facing parabola, and we can find the roots of this. And the roots, again, what we're using is our pattern recognition. We are looking at this and saying, we know we've got a quadratic here. What can we do with a quadratic? Well, we can find the roots, and this gives us that g of x is equal to x minus 3, x plus 1. Okay? Alright, x minus 3, yes, x plus 1. Perfect. Okay. So from that, we know that this has roots at x equals minus 1 and x equals plus 3. Okay? So we can draw that. So I'm going to rub all this off, and then we can look at plotting this function here. Okay, so we want to plot g of x equals x minus 3, x plus 1. It's an upward facing parabola. We know that it cuts at minus 1 and it cuts at 3, so it's going to look something like this. Okay, it cuts through there at minus 1 and it cuts through there at 3. Okay, but in fact, what we want is not this function, but we want the absolute value. We want this function, the absolute value of this. All we ever do when we have any graph, any function, and we plot the absolute value, is the absolute value function says, if we've got a positive value for our function, leave it as it is, and if it's a negative value, then just change the sign. Okay, so here we have, let's do this in white, this is g of x, and we want to plot f of x. Okay? So the values here, the value on the y-axis of these here are all positive. So nothing changes there. And these here are all positive. So nothing changes there. So all we have to do is this region here where there are negative values, we simply switch the sign. And switching the sign of the y values means reflecting it about the x-axis. So here's the x-axis. All we're going to do is flip this, the part which is negative, about the x-axis, and we end up with this. Okay? So that's it. So this is the function. It was very simple. We plot the function without the absolute value sign, and then to apply the absolute value sign, we take anything below the axis, and we flip it above the axis. So what we're actually doing when we're asking about the inequality is we're asking, okay, here is the line x equals 1. Y equals 1. This is the line y equals 1. And we want to know for what values is the function less than 1. Okay? And the function here and here is less than 1. So we're looking at the yellow curve here because it's the absolute value. So actually it's this region here and this region here, not including the line which is 1. And that's those are the two regions that we found when we solved the absolute value inequality, using the piecewise function method before. Okay? So this is an example of how you would plot this function here, but we could also ask about other functions, and the example that was asked for was a function, a linear function, absolute value, plus a constant. So let's look at that. Okay, so how would we plot, let's say, y equals x minus 3, what have we got? Let's say plus 4. So x minus 3, absolute value, and then all plus 4. Again, let's break this down. So let's first of all plot instead y equals x minus 3. Okay? Well, that is simply a function that looks like this. got gradient 1, it cuts through minus 3 when x is 0, y is minus 3. So this is the graph, y, x. This is the graph of y equals x minus 3. Okay, so what do we do if we want to calculate the absolute value, if we want to plot the absolute value graph of this function? Well, again, this is going to stay the same because these values are all positive, and these values are negative, so all we're going to do is simply flip them around the x-axis. Okay, so this is going to become this. Okay? So this is the graph y equals x minus 3 absolute value. And then if we want to add some constant to it, so I'm going to do that on the same graph. So if we want to add some constant to it, let's do plus 4 like this, then that's going to simply raise the whole thing up by a constant. And it's going to look something like, so all points have simply been raised by 4 units. Okay, the scale is a little bit wrong here, but you get the general idea. Okay, so generally when you want to plot anything with an absolute value, be it a simple linear function like this or a quadratic, plot the function without the absolute value first, and then see what the absolute value does to your function. Okay, I'll leave it there. If you have any questions, leave them in the comments, and I will answer them as soon as I can. Okay, great.